space technologies are delivering greater value to a more diverse set of stakeholders than ever before. Earth observation data especially can deliver great value in diverse applications such as environmental monitoring, critical infrastructure surveillance, flood mapping, or maritime surveillance. Numerous Luxembourg-based space players are using EO data in their business models for these purposes. In addition, the use of machine learning foundation models are gaining traction in the remote sensing community, thanks to their adaptability and generalization potential. These models could be a game changer, particularly for synthetic aperture radar data users, as the complexity of SAR makes it difficult to apply analytical processes consistently across different locations and times. Building on their work from 2023, the FDL Europe Challenge aims to further refine the best practices in constructing such a scientific SAR foundation model. It is anticipated to have a substantial impact, unlocking numerous applications, particularly in nighttime, in areas obscured by clouds, and to assess the impact during natural disasters such as flooding. Hence, the Luxembourg Space Agency is more than happy to support this challenge together with Luxembourgish partners LuxProvide and RSS Hypo.
Hello everyone, we are a SAR-FM team. Let's explore what we did for 8-week FDL challenge. Our team made up of 2 researchers. I am Karthik and Andri. We both are ML experts. Then we have an excellent faculty, Guy, expert in hydrology, and Freddie and Rahul, both are ML experts, as well as Earth observation experts. What is a SAR? It is a synthetic aperture radar. It's an active sensor. It transmits and receives microwave signals. It can work day or night at any weather. It is a perfect for Earth observation. The traditional machine learning models used for Earth observation, it requires large amount of label data. And these task-specific machine learning models don't generalize well on SAR data to different geographical region. In this example, the models trained on Puerto Rico not generalize well on Cairo. Yes, the foundation models may provide a solution for this. But what is a foundation model? The foundation models are new class of AI. It is trained on a large set of unlabeled data in a self-supervised manner, where a large pre-trained model encode information as a lattice representation called embedding. These foundation models can be quickly and computationally in economical manner adapted to various use cases. In this project, we aim to evaluate their potential of the challenge relevant to Luxembourg flooding. This accurate map of Luxembourg flooding are critical for supporting relief and recovery. So the SAR data is ideal for this sort of mappings. The foundation models are being developed by NASA, CLAY, and FDL, and there are many others. How can we efficiently choose the best foundation model for a range of use cases? We have built a new toolbox and dataset to assess this foundation model for a set of given tasks. The Maestro is used for assess the foundation models, and we have used the Maestro to choose the best foundation model for mapping floods in Luxembourg. That leads to a new world-first SAR dataset. As I said, Maestro assess the foundation models by using technique called probing. We generate the embeddings from various foundation models using Earth observation dataset. This generated embedding is sensible to various use cases like predicting tree cover, permanent water, and built environment, as well as various geolocation. Our toolbox Maestro identify the best foundation model for your use case based on the results generated from these embeddings. Why this toolbox is needed? Because Earth observation foundation model, it's not like large language models. The large language model we will use day by day, it's a ChatGPT, uses this simple textual data as the input is very, very simple. But our case, the Earth observation foundation model uses the complex input data, which are multimodal and image cubes. I said many times, embeddings, what's really is embedding? It is a compressed representation of input data. In an embedding space, the same object live together like chicken and cats, and different objects like apple and chicken are far apart. Let's see an example. We pass this Sentinel-1 image to a foundation model to generate embeddings. This foundation model doesn't aware of our use case. Our use case here is prediction of water and land. And these are these embedding generated from the foundation model. The foundation model generated embedding, it can easily distinguish between water and land. So this shows us the embedding contains a meaningful information of Earth observation data. To assess these embeddings, we used various probes. The two important ones are linear probe and segmentation probe. The linear probe can estimate total amount of percentage some object present in this image, like total percentage of trees in a given image. Likewise, segmentation probe tell us where the thing is located in the image, like tree segmentation. Andrew will walk us through our experiments and results of Maestro and Welfare SAR.
Yeah, hi everyone. So yeah, we did a few amazing things. As Katak said, we have developed a set of tools to make computationally cheap but effective probes that allow us to find an optimal foundation model. And optimal means that model might differ depending on the architecture, on geography, other stuff. And in this figure, you can see that how simple linear regression, most primitive in our model, applied to the embeddings produced by the corresponding model can estimate which foundation model would most likely be the best for a given task of predicting, in that case, the percentage of built environment on satellite image. Yeah, so we can also suggest which training data should be used for downstream tasks, for example, permanent water detection, specifically in Colombia. It is important to understand that, we need to find some alternative to replace the data in Colombia because there is not much data about Colombia. So using Maestro Toolkit, we can find an answer, and Maestro providing us with answers that we should use Clay with Sentinel-1 data from the United States. Now, this is a segmentation probe, and this segmentation task is much more complicated and requires a lot of experimentation. But we found that the best practices could be achieved. As you can see on this slide, there are embeddings extracted from the same foundation model with quite different results on the left and right, and we should be careful of what we're doing. The second huge deliverable is our VOD-flood SAR dataset and the model, which is a continuation of last year FDL, but we changed the modality from optical to SAR, obviously. We collected new data, proposed brand new model. The dataset consists of several flood events, and for each image, we have Sentinel-1 images before and after the flood event, and of course, the flood mask. So this dataset, the foundation model selected by Maestro, and segmentation probe output together formed a new flood detection model that we tested on more than 2,700 image files of the Luxembourg flood event of 2021. As you can see, the results are fantastic. Note that cloud that covers a part of S2 image, it is a big problem, but for our model, it is no longer an obstacle because we are using SAR data, that was all about. And yeah, we are using Sentinel-1 images to do that. So our future work, and as our contribution to the community, we will release the full data set, all data that we used for experiments. It's more than 10 million images or 20 terabytes of data. This is triplets of Sentinel-1, Sentinel-2, and ESL word cover labels. This data set contains seasonal data. It collected for the whole world, so it could be really useful for running our probes and generalized well for different regions. Finally, we have performed more than 2,000 experiments in 35 testing regions. We used 8 state-of-the-art foundation models from NASA, Clay, bigger snaps, and of course FDL. We also built a segmentation probe of Maestro based on a wonderful library called Segmentation Models PyTorch, which allowed us to use more than 500 encoders, 9 segmentation decoders for those experiments. And as for VOD floods, it is a well-polished data set consistent with 12,000 images, including the Luxembourg. It is an end-to-end pipeline with 8 currently foundation models that we can use for flood mapping. among other things. Finally, yes, our future work would be to add even more foundation models, state of the art for Earth observation, maybe from some other directions. We would add even cheaper probes to define which foundation model could be used for your specific downstream task. We plan to utilize state-of-the-art segment any change approach from Facebook. It's very good, I think. And of course, we had some success with one-shot learning for regression task, and now we are doing it for segmentation task as well, which is very challenging technical thing, scientific even, not just engineering. So yeah, thank you very much. Thank you for your time.